Assalamualaikum warahmatullahi wabarakatuh. My name is Syahmie Idham bin Mohd Sharulnizam. So today I will be presenting on my final year project proposal entitled Muscle Activation Analysis of Badminton Players with Different Forehand Service Techniques by using SEMG. Project summary. The project is about studying muscle activation analysis of badminton players using different style of serving using SEMG device. Alright, so the main purpose is to study the efficiency of various serving techniques in terms of energy needed for muscle activation. So, the lesser energy consumed, the higher efficiency of the serving techniques. So, this is what we are going to study. Serving is the basic skills needed by every badminton players, either for the professional levels or the beginners. In order to study the muscle activation, alright, we will conduct an experiment using a surface electromyogram, or we call it as SEMG device, which this device will collect the muscle activation data of the specific muscle related during the serving actions. So the data collected was then be used to obtain a graph, or we call it as myograph, for muscle activation during the event of serving. Introduction. So what is surface electromyogram, or SEMG? I believe that not all of us knows what is SEMG and how it works. SEMG, or surface electromyogram, is a commonly used technique for studying muscle activation and can provide non-invasive and continuous measurements. Systematic studies of the use of SEMG in sports environments have been conducted over the years and are primarily based on sports activities and how it works. An active muscle will generate an electricity impulses. So this SEMG will detect these impulses and converts them into a reading, or we call it as myograph. Okay. The next one is why badminton. Okay, the first one, badminton sport is not an extreme sport that requires extreme movement, so it is very compatible for the SEMG devices to be used. And the second one is that many research on badminton has been done, but very minority of them are studying about these serving techniques. So this is why I'm here to study the serving techniques. Okay, next is how many serving techniques in badminton? Okay, actually there are two major serving techniques. The first one is forehand serve and backhand serve, but for this study I will just be focusing on the forehand serve, and the muscles that involved is the forehand muscle or the flexor muscle. Moving on to the next part, literature review. The first one is forehand serve. Every badminton point in the world begins with a serve. Serving in badminton have various types of techniques and also strategies depending on the individuals. Different individuals have different style of serving, but based on the previous study, it shows that forehand serve is one of the most popular in badminton sport. Forehand serve is divided into two. The first one is low serve, and also the second one is high serve. Basically, the fundamentals of both serve is the same, and the muscle activates during the serve also the same, which is the arm muscle, or to be exact, the flexor carpi ulnaris muscle. Flexor muscle. So what is flexor muscle? Flexor muscle is actually the forehand muscle. Flexor muscle is a collection of 5 muscles, which are pronator teres, flexor carpi radialis, flexor carpi ulnaris, palmaris longus, and also flexor digitorum superficialis. But based on the previous study, among those 5, the major muscle that involved during the action that involve the movement of wrist and also arm is the flexor carpi ulnaris. So in conjunction with the serving action, which involve the movement of wrist and also muscle, so the focus of the study will be to the flexor carpi ulnaris muscle. So that is the muscle that we are going to study and also evaluate the muscle activation of that particular muscle. Main objectives. So there are 3 main objectives of this study. The first one is to analyze the muscle activation of flexor muscle during badminton serve, of course, using the surface electromyogram or SEMG. The second one is to compare the result of different serving skills and technique. So we have low serve and also high serve, and also we have a right-handed and left-handed respondent. So all those results will be compared. Okay. The third one is to determine the best energy consumption serving technique. So based on the results that we gathered, we will determine which is the best energy consumption serving techniques for badminton sport. Scope and limitation of study. As I mentioned before, this study focuses on the muscle activation analysis of a badminton player during the action of serving. So for this study, we have decided to choose 5 number of respondents to be evaluated. And of course, the respondents consist of badminton players from various levels, starting from the beginner, amateurs, and also professional level. Alright, and the most important thing is that the background of the respondent need to be checked, so that they and need to make sure that they don't have any previous injuries, such as ankle wrist or any injuries that may affect the readings, and they need to be in a very good condition to be evaluated. Okay, methodology. Experiment is the method used in this project to collect and obtain data. As mentioned before, SEMG is used to analyze the muscle activation during serving. So it will detect the electrical activity produced by the skeletal muscle during certain activities and visualize it into sets of data and graph, or we call it as myograph. Okay. Since the only way to collect the data of the muscle activation is by using the SEMG devices, the experiment need to be done in a controlled area or lab, or any suitable places for running the experiment, such as private badminton court or any spacious area that is suitable to run the experiment. So the data of the muscle activation will then be gathered using Pro-EMG software that is connected to SEMG. So, and the results may be reviewed immediately after every experiment. Okay. So we got here is the procedure, the whole procedure of using the SEMG. Okay. The first one is to make sure all the devices are in a good condition. Next is, once all devices have been connected, open the Pro-EMG software and then check the connection and reading on the Pro-EMG software and make sure that everything is connected. Then check the respondent's medical history for safety purpose. Next, determine the specific muscle that want to be studied, like for this case, the specific muscle is the flexor carpi ulnaris, which is located here in the arm muscle, in the arm area. And then next, mark the center of the muscle. Then identify the muscle of the respondent and clean the area of the muscle. Then you need to palpate the muscle. Next, swab the alcohol around the muscle area and wait for 1 minute. And then place the electrode at the right position with a gap of 20 mm between each electrode. And next is execute the serving action with all the electrodes and devices connected. Repeat for a few times to get the accurate readings and collect and study the data. Okay, for the flow chart, so basically it is almost the same with the procedure that I explained before. First one is set up the SEMG devices, check respondents' medical history for safety purpose. Next, prepare respondents and attach electrode to the muscle parts. Next is testing. We have low serve, high serve, and also flick. Repeat 3 times for every technique, and every players. Next, collect and study data together. That's all. So for the results, as you can see, that is the myograph that I had obtained from my previous experiment. It is actually quite a good result because you can clearly see the difference between the resting phase and also the working phase. For the flat area is actually the resting phase, while the area with the higher amplitude is the working phase. The time interval set for this study is 10 seconds. 3 repetitions for each posture is to get the accurate average reading. So from the graph, we can conclude that the average reading of electrical impulses of the flexor muscle during the action of forehand serve is around 3 volts. So the average is around 3 volts, while the maximum amplitude is the maximum muscle activation energy is at the almost 4th second, which is at 3.4 something volts. That is the maximum electrical impulses of muscle activation. I think that's all from me with that. Thank you.